a sine x by itself. Okay? And then I've got to turn everything else into cosine. So I'm going to take this sine x and break it up, and I'm going to write it weird. Okay? So I know I have to break it. If I'm going to break it off a sine, what's going to be left? Sine what? Good. So sine squared x, cosine to the fourth x, and I'm going to put my other sine x at the back. So it's in the right spot. I know I want to get rid of that sine. Could we use Pythagorean identity? I got to introduce it, somehow turn that sine into a cosine, right? So I'm going to put this cosine to the fourth x, sine x out back. What do I get to replace sine squared with? 1 minus cosine squared x. Good. Now look at what I have to get to. Am I going to distribute everything in? Do I want to distribute the sine in? No, all I want to distribute in is the cosine to the fourth. Okay, thank you. All right, so we've got cosine to the fourth x. What's cosine squared times cosine to the fourth? 6. You're adding your exponents, right? Times sine x. Did I get what I wanted? Yeah. Yep. All right. Looks like we got one more of those. It's exactly the same. Okay, so I want you to try that one. It's identical to this last one, only I put the I kind of reversed where the sines and cosines are. So everybody try 21. Okay? About 15 more seconds. Okay. Do you agree with what I did so far? We broke off one of the cosines because that was what it said to have hanging out at the back. All right. I know I've got to turn this cosine into a sine. What are we going to replace it with? Good. And then we've got this sine to the fourth x and cosine x. What do I want to distribute in? Just sine to the fourth. So sine to the fourth x minus sine to the sixth x times cosine x. Did we get what we wanted? Yeah. Those ones look worse than they are if you know the trick to break it off, right? Okay. We should be getting really good at Pythagorean identity, right? All right, the next one are some of my favorites. Oh, not that. They're some of my favorites. So you're guaranteed to see one of these on the test. Okay. You have to be able to add to 90. Can you all add to 90? I hope so. Yes. Okay. So we're going to be using the little cofunction identities, which are the third window, that first column in the third window, because pi over 2 is the same as 90, right? So it's that window that we're going to use. All right, so which numbers in here?
40, 50, 72, 18.
Okay, 40 and 50 would go together, and 72 and 18 would go together. Okay, so I'm going to line those up. So I'm going to say sine squared 18, maybe. Pen is, I keep forgetting to go get batteries for the pen. Doesn't want to let me write today. There we go. Sine squared 18 degrees plus sine squared 72 degrees. So all I'm doing is rearranging right now to match up my 90s. Sines, I lost a squared, of 50 degrees. So all it's done is I've rearranged it. Okay. The whole thing, the goal that we're going for is sine squared plus cosine squared equals 1. Okay? We're going to use that Pythagorean identity. Problem is I got to turn that into cosine. Okay? So In order to do that, if I use my cofunction identity, I know that I can take 90 and subtract 72. What does that give me? 18, and that turns into cosine of 18. So sine of 72 is the same as cosine of 18. Just like sine of 30 we've seen is the same as cosine of 60. Okay? So sine squared 18. All right, now let's try this one. So I'm going to write down my sine of 40. I'm going to keep the first one. You can change whichever one you want. It doesn't matter. All right, so if I do 90 minus 50, what does that give me? 40. And I flip the sine into cosine. And it doesn't matter whether you start with sines and cosines, you flip it into the opposite. Now what that allows us to do is, as long as this thing in here is the same, I can do sine squared plus cosine squared equals what? 1. And again, sine squared plus cosine squared equals 1. So my answer is 2. I don't know why I like doing these, but I like doing these ones. Okay? So I get it. I have letters, and I turned it into a numerical answer probably. All right, let's try it again. Got one more of those. Okay. So let's match up what we need to match up. So what would 23 go with? 67. Okay, so plus, and notice I started in cosines instead of sines. And then that would mean that the 56, does it match with the 34? Do those add up to 90? Cosine squared 34. All right, so I want to take my cosines and turn them into what? Sines, right? Does it matter whether I do the 23 or the 67? No, you pick whichever one you want. I'm going to do the 67, okay? Keep the same pattern I did last time. All right, so I now know what 90 minus 67 is, which should be 23. The shortcut is it should add up to, it should be that one right there. And I'm going to flip the cosine into a sine. Isn't that neat? All right, I'm going to drop this guy down here. But all we're doing is we're using that cofunction identity. Okay? All right, and then again, I'm going to take the 34. I'm going to go 90 minus 34, which is, should be 56. We get to flip the cosine into a sine of 56. And now that these guys are the same, sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1, and my final answer is, my favorite trick on the test, because we always do that ones that just add up to 2, is to give you 3 of them. So if I give you 3 of them, what should it add up to? 3, right? Okay. So you almost have the answer for the test, right? Okay, last one that we've got to do. Okay. This one says we have to verify the identity and then determine if the identity is true for the given value of x. So there's a couple of things that we've got to deal with here. So I'm going to do part A here. I'm going to verify it. It really doesn't matter which side I do first. I'm going to choose the left side to try to get it to turn into the right side. So it wants me to turn, so notice it wants me to turn these 1s here into tangents, doesn't it? So instead of multiplying by a conjugate, I'm going to try a new trick. I'm going to try to multiply by tangent. Because that would turn these 1s into tangents, wouldn't it? Okay, so let's try that this time. What is another name for cotangent?
1 over tangent.
It's 1 over tangent. Why is that good? We would get to cancel. That's right. I'm sorry, I'm not writing cotangent. I should be writing tangent. 1 over tangent. So that's why I chose to multiply by tangent. Times tangent x over tangent x. So now what we're going to do is we're going to take those tangents and distribute them in. Tangent over tangent is just 1. That's why I'm allowed to multiply by it. All right, so tangent x over tangent x is going to turn into what? 1. Negative 1 times tangent x is negative tangent x. Okay. Does my numerator look good? Yep. Okay. Tangent on the top over tangent on the bottom would be what? 1. 1 times tangent is